Hey guys, we're going to have a quick look at a video on limiting reactant problems. So up until now we have looked at some moles calculations whereby you've been told what mass of reactant you had, and you've been asked usually to work out what mass of product, C and D in this instance, you would make. So your strategy there is to work out the number of moles of your reactant by using number of moles equals mass divided by the RFM. Okay, and you get the moles, and then you take the moles of, let's say it's A, and if you're asked to work out what mass of C you would get, you take the moles of A, or the moles of A, and you multiply it by 3, because 1 mole of A gives you 3 moles of C, and you take that moles and you multiply it by the RFM of C, and that would give you the number of grams of C that you would make in that particular reaction. Alternatively, if you were working on the mass of B, you would take your mass of B, convert it into moles of B, again by dividing the mass by the RFM of B. And if you were converting that or working out the mass of D this time, it's a 2-to-1 ratio, so you would divide the moles of B by 2, and so you have B over 2 moles, multiply that by the RFM, because mole times RFM would give you the mass in grams of, in this case, D. And that's sort of how we've been working so far. Okay. Now, alternatively then, you might be asked, said, well, okay, work out what grams of C are made if we start off with 3 grams of A and B is in excess. Well, this time we can ignore B because there's more of it than is needed to make sure all of A reacts. So A will control, the amount of A that we have would control how much C and D we made, and this is called, therefore, my limiting reactant. It limits or controls how much C and D you would actually make. Now, again, we would do sort of the same thing in that we would take 3 grams of A divided by the RFM of A, and that would give me moles of A. In this case, if we were looking to do C, we would multiply that by 3, because 1 mole of A gives me 3 moles of C, and then we would multiply that number of moles of C by the RFM of C, and again that would give me whatever grams there is of C. Again, just using our mass in grams equals number of moles times the RFM. Okay, and that's easy, but in these limiting reactant calculations, you're not going to be told which one's in excess. You will actually have to work out which of the 2 reactants is in excess, and therefore which one is the limiting reactant and controls how much of the product is actually made. So let's have a look at a sort of an analogy to maybe help explain that. And the one that I use is if I'm making, let's say, 1 apple pie. Okay, excuse my artwork please. Okay, looks just like an apple pie to me. And let's say I need, in order to make my apple pie, that's an apple by the way, okay, we need 5 apples, and I need some pastry. I need other things, but I'm not going to start drawing in everything here. So let's say that's my pastry, and I need, let's say, 1 packet of pastry. 5 apples gives me 1 apple pie. Okay, well, if I can treat this a bit like a chemical equation. So let's say I have got 5 apples, and I've got 1 packet of pastry. How many apple pies can I make? 1. And there's none of either left over, so neither is in excess. Let's say I have 5 apples and 2 packets of pastry. How many apple pies can I make? Well, I'm limited by the number of apples that I have. I only have 5 apples. I may have 2 packets of pastry, but I'm going to have these in excess, and they're in excess by 1 packet of pastry is going to be left over, so I can still only make 1 apple pie. So my limiting reactant there, the one that controls how much product or apple pie I can make, there's the 5 apples. Let's say then this time I have got 15 apples, and I've got 2 packets of pastry still. Well, I've got enough apples to make 3 pies, but I've only enough pastry to make 2 pies, so this time my limiting reactant is my pastry, and I can only make 2 pies, and my apples are in excess, and 2 packets of pastry will require 10 apples, so I've got 5 apples left over unreacted or unused in the recipe. And that's kind of how it works for limiting reactants in chemistry and in chemicals, except we turn mass of things into moles, and then we compare the moles instead of comparing packets of pastry and packets or numbers of apples. So we'll do a couple of examples and see how we get on, and hopefully that will clear up any. So I'm going to go to your notes so you can follow this if you're at home. So we'll go to the notes and we'll go to the first one in the notes. I'll do the first one and then I'll do maybe one from number 3 here, and we'll see how we get on. So given the following reaction, balance the equation first, so we'll do that now. Okay, if we start, so I'll try and set that over to one side so we can try and look at that as we do it. So let's balance the equation first of all, and again, it's a combustion equation. So the best way to balance a combustion equation is by doing it alphabetically, so carbon, hydrogen, then oxygen. So I have 3 carbons here, I need 3 there. I have 8 hydrogens there, so I need 4 times 2 hydrogens there. And the oxygens, finally, I have 6 and 4 is 10, so I have 5. So that's the equation balance, right. So I'm going to start with 14.8 grams of this, whether you know it or not, is a thing called propane. So I've got 14.8 grams of that. Okay, and I have 3.44 grams of my oxygen, and I've got to determine which one is the limiting reactant, right? So I have a 1 to 5 ratio here, which is really very important, and we've got to bring that into consideration. So let's get the RFMs of these first. So this is 3644 is the RFM of that, and oxygen is 2 times 16 is 32 grams. Okay, so we'll go from there into N for number of moles. So we'll go 14.8 divided by 44 there, gives me 0.336 moles of that, and 3.44 divided by 32 will give me 0.1075. So immediately it looks as if this is my excess reactant, but we just need to be careful because we've got a 1 to 5 ratio here. So if I have this number of moles of oxygen, which I have, how many moles of propane would I need to react with it? Well, I would need 5 to 1. I would need a fifth of that. Okay, so I would need 0.0215, but I actually have 0.336, so I have lots more of this than I actually need. So indeed, this one is indeed my excess, making that one my limiting reactant, which means it will control how much of this and this I will be able to make. Okay, so let's see. The first question is determine how many moles of determine the number of moles of carbon dioxide produced. Well, if this is the moles of oxygen and it's a 5 to 3 ratio, okay, I will divide that by 5 and I will multiply by 3, okay, and that will give me 0.0645 moles. So I get 0.0645 moles of that would be made, and if I do my waters again, I take my 0.1075 and I divide by 5, multiply that by 4 this time, gives me 0.086 moles of that. Okay, it's a 4 to 5 ratio, and just check, guys, that you don't do a 5 to 4 by mistake. So this number should be smaller than that number, and this number should be smaller than that number, and smaller than that number, which they both are, so I'm pretty sure I've hit the right buttons on my calculator. So multiply these by the RFM times by 18, this one here times by, times by 44, okay, so times by 18 means that I would make in this instance 1.548 grams of water would be produced, and 0.0645 And 44 tells me in terms of carbon dioxide, I would make 2.836 grams of carbon dioxide. Okay, so hopefully that sort of clears that up. I'm going to do one more as an example, just to let you know how to do another one, I suppose. Okay, so we'll take a wee look at we'll just go down to, we'll go to number 3 in the notes questions there, and we'll see how that one is. Alright, so again we'll just write out the equation. So it's aluminium oxide reacting with iron to give us iron 3 oxide, and we're also getting some aluminium made. Okay, so the first thing we need to do there is we will need to balance that reaction. Okay, so let's just do that first of all. So our irons, we've got 3 irons there, gives us 3 irons. Okay, our oxygens is 4. We're going to have to find a common multiple of 4 for here and 3 for here. So that's probably going to be 4 of those and 3, because 12 is our lowest common multiple of those two. Brings my irons there. I'm going to need 9 irons there, and I'm going to need 4 times 2. I'm going to need 8 aluminiums there. So let's just double check that we have got the right everything sorted before we move on. So we've 8 aluminiums and 8 aluminiums. We've 9 irons, and we've 9 irons. Our oxygens here are 12. Our oxygens here are 12. So that looks fine. I can't reduce it any further. I've got a 4 and a 9 and a 3. So that's as low as I can get that in terms of common multiples. Right, let's fill in what the examiner tells us. So we've 24.5 of that, and we've got 10.2 grams of that, and we're going to work out how much of our product we would make in each instance. So again, let's get our RFMs of our, so that's 56 is atomic mass of iron. Aluminium here is 54 plus, that's 2 aluminiums, plus 16 times 3. Okay, so it gives me 102. Let's convert that into moles by taking mass and dividing it by the RFM. So 25.4 divided by that will give me moles of 0.249. And again, just sort of mentally check or estimate that your answer is right, guys. That looks fine. It's 25 over 100 roughly. Should be about where I am there. And again, do the same with this one. So that's 0.182. And again, that looks about right. So I need to work out now which one's in excess. Immediately it looks as if it's this one, because this is a bigger number, but don't forget I have my 9:4 ratio here. So if I have that number of moles of aluminium oxide, I need to divide that by 4 and times it by 9 to see how many moles of this I would actually need. Okay, so 0.249 divided by 4 times 9 would tell me that I would need 0.56 moles of that would be needed to react with 0.249 moles of aluminium oxide. So that means that indeed this is in excess. Okay, and that is my limiting reactant. Okay, so I'm going to try and work out how many moles and then what mass of these products are made. So I have 0.189 moles of iron, and that will make a third of that in terms of moles of iron oxide, okay, because it's a 9:3 ratio, or a 3:1. So the moles of this that would be made would be 0.182 divided by 3, okay, would be, moles would be 0.0606. And again, I'm just going to check off the top of my head, does that look right? And it does, it's a third of 0.18. Okay, and then remember, moles equals mass times, mass equals moles times RFM. So I need to take this and multiply it by the RFM of my iron oxide compound up here, okay, which is 3 56s and 4 oxygens, 4 16s. Okay, so that is a total of 14.07 grams would be the answer to that. Okay, let's move across to the aluminium then. Okay, so aluminium, we have a ratio of 9 to 8. So we need to take our 0.182, divide by 9 and times that by 8. Okay, it gives us a moles of 0.1617. Okay, and again just check or estimate that that looks right, and it does, looks fine. Okay, so again we multiply that by the RFM of aluminium, which is 27. It's just the atomic mass of aluminium. Okay, and that gives us a mass this time of 4.368 grams of aluminium would be made. Okay guys, those are pretty difficult ones in the whole concept of GCSE. Hopefully you're able to see what we've been doing there, how we work out the limiting reactant, how we work out the excess reactant, and then the fact that the limiting reactant is in actual fact the one which controls the amount of product that you should be able to make. Okay, any problems or queries with that further, please ask us.